All right, let's go ahead and get started here. I know some of you probably not too excited about this session. What if I added some fireworks? What do you think? All right. Well, welcome to the wonderful world of Windows session. I am William Yu. I'm the Windows and Linux framework engineer here at Xojo. And let's go ahead, get started. So judging by all the MacBooks I see here, you're probably wondering, what is this guy talking about? What is so wonderful about Windows, right? Well, I don't work for Microsoft, so I'm not here to promote Windows, but I am here to talk about some of the wonderful things that we've been doing in our Windows framework here. But first, let's take a look back at the evolution of Windows to see how we've come to this point. Well, we no longer support XP, and neither does Microsoft. It did introduce some interesting features that are still in use today. One of the things it introduced are themes and visual styles for Win32 controls, which we use. They've also introduced HiDPI+, which was meant to be the successor to GDI. And we've supported HiDPI+ for a while until we eventually moved to Direct2D. Next came Windows Vista and Windows 7. In Vista and Windows 7, they introduced what they call the desktop window manager, which did a bit of compositing. So if you noticed in those versions of Windows, it flickered a little bit less. They also introduced Direct2D and Direct-Write as the replacement for HiDPI+. They also added support for HiDPI, which not too many people adopted because at the time it was really expensive to own a HiDPI monitor, and it wasn't very common back then. But they supported virtualization, so even though your app did not promote support for HiDPI, they virtualized your interface so that it scaled properly. Next came Windows 8. They made the desktop window manager now became permanent. I don't know if you know, back then in Windows 7, there was an option to disable it because on some computers, DWM made it a lot slower. So a lot of people disabled it in Windows 7. But in Windows 8, you didn't have the option. It became permanent. And then they added per monitor HiDPI support. And they also introduced the Windows Store, and you know how popular that is. All right, after Windows 8 came Windows 10. That's right, because they can't count. They skipped 9. So the adoption of Windows 10 was significant due to its free upgrade. And they also, in that version, introduced the Universal C runtime. This is the refactored Visual C++ runtime, which they just called the Universal C runtime. This is essentially the heart of your application. And we've been using it and requiring it since 2016. And if you want to be technical, it actually was introduced in Windows 8.1. So let's talk about Xojo on Windows. We use native Win32 controls, so not .NET, WinForms, not WPF. Those are other UI toolkits on Windows. And Win32 controls supports visual styles, which XP introduced. We've added support for Direct2D. This really helped in our HiDPI support. And as mentioned, we've moved to the Universal C runtime, as well as supporting ActiveX and COM. So talk about some of the recent milestones in 2018 R1. One of the things that Jeff mentioned in his keynote is we now support a 64-bit debugger in the Windows IDE. And another big change is our move to what we call a pseudo-transparency model on Windows to eliminate flicker. So why did we move to this new model? Well, surprise, surprise, people came to us making apps like these. And they wanted this to not flicker. So obviously, not everyone's going to make apps like these, but certainly you have apps with layers and controls, and you would prefer it to not flicker like this. So let's talk about some of the Win32 UI control issues that we're up against. The first thing to note is Win32 is not naturally transparent. However, it does have an option to enable it, but of course, it flickers. It's also not composited by default, but again, it does have an option to enable it, but it's really slow. So why did we continue using Win32? Well, for one thing, it's not dead. Microsoft still uses it in some of their apps, and there's a lot of apps that still use it, so I don't think Microsoft's going to kill it anytime soon. So even with all these issues, Win32 controls have all the capabilities that we need to create a flicker-free application. So with a pseudo-transparency model, what we did was we got rid of truly transparent controls. This made erase background obsolete because we handled drawing the background for you. This pretty much handles compositing. So if you have a layer control, we draw the background of the child control, and then we draw the child control on top. And this is not a new concept. WinForms actually uses this model in their own application, and we kind of borrowed it. So, and it's been working for them, and hopefully it works for you guys. So let's see the pseudo-transparency in action. As you can see in R3, 2017, we got a lot of flicker. But with this new model that we introduced in 2018 R1, there isn't any flicker at all, and you got transparency because we handled the compositing. So what are the expenses? So let's say you have a lot of transparent controls on your window. With this new model, what we're doing behind the scenes is compositing for you. And so if you have over 100 canvases that are transparent, that means 100 calls to draw the background. And this is what makes it slower. Another downside is that since we don't support truly transparent controls anymore, you can no longer partially overlap transparent controls. However, you can easily work around it by containing the two controls. So here we have a canvas that's completely contained in another canvas, and so that still works. Let's go ahead and take a look at some demos so you can understand some of the differences that we've made. First, let's look at some of the difference between 2017 and 2018. All right, so let's take a look at this interface. So on the left-hand side, we have a couple of canvases, transparent canvases, over some Win32 controls. And this worked in 2017 because we had truly transparent controls. So overlapping, partially overlapped controls would work. Putting transparent canvases over one of the tab panels, one of the tabs works, and also putting a transparent canvas over a progress bar would also work. So let's see how that looked in 2017. So you can see that canvas drew a red button and is truly transparent. It's also over tab 1, which is also transparent. And you got partially overlap controls, which worked before. So now let's take a look at what happens today with 2018 R1. All right, you notice there that because we're not using truly transparent controls, this red button is no longer transparent. And this transparent canvas that's over the tab, the second tab, draws a white box. So we're not handling drawing the background of that control. And partial overlap controls also no longer work. So what is working? Let's take a look at these two again. So if you look at the middle container, you'll notice that they're pretty much the same. We have a special background, we have a rectangle that's white, and all the controls inherit the background color. So that's all working, pretty much the same, except for that group box you see in R3. So what is different? Let's take a look here at the last column. With pseudo-transparency, we've made Win32 controls look transparent because we're compositing now. And so the checkbox in R3, while it is transparent, we don't actually handle the transparency, otherwise it'll flicker. So we decided not to handle that. But in R1, since we're handling the background, drawing the background, we can now support transparent Win32 controls. So you see the checkbox is transparent, the slider is also transparent, and the group box is also transparent. And again, I have in this last section a workaround for partially overlap controls. You can just contain one canvas on top of another, and that's perfectly fine. Okay, so that's the difference there. Let's take a look at scrolling, because there's a lot of people with projects that scroll many controls, and before in R3, scrolling would flicker a lot because we're moving controls, drawing the background, and you get that flicker effect. Let's see what happens in R1. So I basically have a container control with a bunch of controls on it, and I'm just moving it up. So by default, when I scroll this thing, you can kind of see, while there's no flicker, the drawing is not perfect, right? This is because we're simply letting system handle the invalidation. And so Windows is deciding when it's ready to redraw. So you can force an immediate redraw by refreshing the whole thing after you're done scrolling, which this checkbox does. So now you can see that it's a lot smoother just by immediately refreshing that container control. We've also added a double buffer property on the container control, which simply composites using the Win32 option to composite. So if you enable that, you can also get a nice scrolling effect. Although the downside to enabling the double buffer property is that it lags a little bit more. And depending on your interface, it might lag a lot. All right, any questions so far about pseudo-transparency? Yes?
You mentioned that you did this to avoid true transparency, but I'm not sure why we're avoiding true transparency.
We avoided true transparency because of the flicker that it causes. As you saw with the moving soccer ball, we had to erase the background and it just flickers. Yes?
What is the underlying
So the question is, what is the underlying thing that's preventing us from having true transparency without flicker? Well, it's a loaded question. With Win32, again, Win32 provides a lot of options, but it doesn't provide a one-size-fit-all option, fortunately. So we can either have true transparency with a bit of flicker, like we had in 2017 R3, or with the pseudo-transparency model, which WinForms.net adopts as well. We can eliminate all flicker with the downside of slower apps.
So it's Win32 that is presenting this like.
So the comment was it's Win32 that's preventing us from getting truly transparent controls without slowing down, without flicker. And the answer is probably. Probably. And we have other options, but those options would be far worse in some ways, far better in some ways. Comment was, unfortunately, Windows users have gotten used to it, and unfortunately, the answer is yes, they have. Even Windows apps, unfortunately, flicker as well. Microsoft Windows apps.
So not being too terribly familiar with the underpinnings of Windows where it's headed with Windows 10, what is the underlying model that's replacing Win32? If there was .NET, is that part of it? Is that where things are, or what's next?
So the question is, what has Microsoft done to improve Win32 by adding additional user interface toolkits like WPF, like WinForms? Yes, they have moved to a composite model, like WPF is. But it is .NET, and there's downsides to moving all our code to .NET, and even the UI, there's challenges there. Yes?
We upgraded internally to 2018 release 1 from 2016 release 3. We skipped all those versions on Windows because of when you made the transition to Direct2D, flickering became much worse. Now flickering is gone, and speed for us internally for now is acceptable, but we saw that it's a lot slower. I also saw a lot of complaining on the forum, and Julian Sapphire asked also on the forum to ask you if you were working on speed for the next release.
So the comment was, they moved from an older version of Xojo to 2018 R1, and they found the speed acceptable but not great. So are we planning on optimizing it some more? And the answer is yes. We are planning on optimizing some more. We have some ideas. So that's the best I can say to that. All right. There's no other questions. Let's move on. Okay, so again, what can you do to speed up your apps? I think the number one thing is to limit transparency. That's the thing that requires us to draw the background of your controls. So as long as you don't have any transparent controls, we don't have to do any additional processing. As demonstrated, partially overlapped controls are no longer supported, so please don't do that. For smoother scrolling, you can enable double buffer. As you've seen, you can also trigger refresh. You can also use this declare, which is very popular amongst Windows developers. So declare basically to prevent a refresh from happening. All right, so let's talk a little bit about ActiveX and COM. So in Windows, we actually use ActiveX and COM quite often with the HTML viewer, the movie player. We've got drag and drop, that's also implemented in COM. and also the new HB socket. If you ever use the Windows IDE, you can add your ActiveX component via the Insert menu and the ActiveX component menu item. It'll bring up a dialog such as this. Simply select your control, and after you select your control, it'll add that control to your project, and then you can drag that control onto your window. So this is an ActiveX control. It's a calendar control offered, I believe, in Microsoft Access. Let's talk about some additional COM features that might be helpful in your projects. The taskbar progress we use in the IDE to show the progress of, for example, loading a project. As you can see in the taskbar area, you can control that little progress down there, and that uses COM. We'll show you a demo of that in a little bit. You can also use COM to extend features, for example, deleting folders recursively. As you know, our full amount class, if you want to delete a folder, that folder has to be completely empty. So I'll show you a demo of how you can work around that via COM. All right, let's take a look at some examples here. Okay, let's first look at that taskbar example. So I have a simple taskbar class which constructs a COM object. And if this code scares you, sorry. But it's simply constructing the COM object off of a GUID. And to find that GUID, just look up Microsoft documentation or the header files. But in this case, I'm creating a taskbar object via COM. So let's go ahead and run this, see what it looks like. So there's a couple options that I've added here. So for the normal progress, it should be green. So I just have a slider that kind of adds that progress. If you can see down there, the progress moves as my slider moves. You can also add an error-looking progress, so it turns red. Again, you can slide it up and down. And they also have an intermediate mode, which simply does that. And really, it's a very simple class. This is how it's constructed. Not too many lines of code. And really, that's pretty much all you need to do to call its progress. So that was using COM. Now let's take a look at another COM example. As I mentioned, this COM example is to extend the feature of deleting a folder recursively. So on this window, I have a button that creates this COM object, and this COM object will recursively delete this folder. So I've extended the folder item to have a delete recursive method. And again, I think the hardest part is finding the GUID of the COM object. And sometimes it has what they call a program ID, which is a more descriptive name than a GUID. So let's go ahead and say, I'll go ahead and bring this, I don't know if you guys can see this or not, but this is our add ActiveX component dialog. On one of the columns is the component name, and on the other column is what we call the program ID. This is the ID of the COM object. So you can construct it via the program ID or its GUID number. So in this case, I'm constructing it using its GUID. So let's go ahead and run this. So the nice thing about this COM object, it allows you to show some UI, just like the Windows desktop when you delete a folder. So I'm going to go ahead and show some UI. I have a folder that I've created that I don't mind deleting, so I'll go ahead and delete that. It's going to ask me, are you sure you want to delete this folder? Say yes. And there it shows the progress. And that took about 10 seconds using COM. I also written a completely Xojo method that also deletes recursively. So let's go ahead and see how long that takes. Same folder, same amount of files. Hopefully you trust me on that one. So we'll go ahead and let it run. And depending on the system, I've noticed that depending on the system, it could be faster, it could be slower. In this case, it took a little over 10 seconds, so it was a little bit slower.
What about just using a shell?
So the question is, what about just using a shell command? Yes, you could do that too. It might be faster. But yes, as you can see, the COM version, it is faster, but also it's nicer because it can either show an UI or you don't have to show a UI. So it's an option if you wanted to show UI in your app. Question?
So what performance benefit do you get about using the COM object versus just declare DLL and use the kernel function?
So the question is, what's the advantage to using COM object over a declare? And the answer is it's probably similar. So it might be the similar type of speed. And in most cases, the COM object might implement itself via that declare, right? So. All right, let's go ahead, go back to the slides. All right, if you're not familiar with Windows, with ActiveX controls, they're not always installed on every computer. So depending on what ActiveX control you use, if it comes from a third party, you're gonna have to create an installer to include that ActiveX control and probably install it on the user's system. The OLE object that we have in our product communicates via HiDPI. So a COM object can promote itself as supporting a dual interface or not. And what that means is if it does not support a dual interface, we need to bind through that COM object through the vtable binding. Otherwise, if it does support HiDPI, that means there's an exposed interface that we use to communicate with it. And what's great about HiDPI is that a lot of scripting program languages like VBA, they communicate with the COM object through HiDPI. So if you're using OLE object, you can also use this OLE parameter class that we have to pass parameters by name and position. So in VB, you can actually construct a call that calls a method by name. And so this is one way to support that feature. All right, let's talk about how to extend some more features. You can use declares to add additional features to your Windows application. You can use it to add additional Win32 controls. You can use it to create transparent windows. And by transparent windows, I mean like window shapes. And again, a popular declare, you can use declares to declare into this function or this message to prevent redraws. And of course, you can extend features by writing a third-party plugin using our plugins SDK and adding controls that way. So I'm going to demo how to add .NET controls in your Xojo app here in a minute. Okay, first let's demonstrate how to add some a new Win32 control via declares. So Win32 supports many controls, and we don't cover all of them in our product, but it's not that hard to extend it. So here, I'm going to add a Win32 command link control. And I've pretty much set up 3 canvases to do that, which I've subclassed a canvas here. And I'm going to just show you a bit of code, see how that is set up. So if you're familiar with Windows, this will all make sense, but I'm just using some declares to create this window, create this command link button, add it to the window, set its order, set its size, and this is the final result. And if you've never seen a command link button before, you could look at the system day and time. I believe some of the items are command link. But they're basically a flat button look. They have a slight animation as I mouse away. You can see it fade a little bit. So what do you want for dinner? I think I'll eat out. All right, so that's a demo of adding Win32 controls via declares. Now let's take a look at creating a window shape. Sometimes you'll see some applications present a splash screen which has an irregular window shape. And through declares, you can set the window region, what region you want to be visible and what region you don't want to be visible. So in this app, I am making a few declare calls to take a picture and make my window that shape. Let's go ahead and run this. You almost need a splash screen for the splash screen. But here I'm just adding progress to that shape. And what's cool is I can click right through that button. All right, now I think I promised you adding .NET control. So I created a .NET control in C++, and I packaged it into a plugin. So what I'm going to demonstrate is adding a WPF-rich text box. This allows you to add spell checking. So down here, I have a rich text box. If I can move that properly. Okay. Right. You might not be able to see it, but there's a spell checking option, so I'll enable that. If I run that. All right, kind of looks like a Win32 text field or text area control, but it's not. This is actually a WPF.NET control. So I'll go ahead and misspell world. You can see I misspelled world. It's highlighting or underlining under red, so I can right-click on it, select how I want to fix that spell check or spelling error, and that's it. So we've added a .NET control in Xojo, and the source code to this plugin it's available in 2018 R1. If you look in the extras folder, the plugins SDK, the source code is right there. I've also added a WPF calendar control, but I won't demonstrate that. All right. Lastly, just some Windows tips. Preferences, 2 places to store them, all in the registry. The first place, if you want it to be global, so all your users can access it, they go in the HKey local machine /software. If you want it just to be local to your user, then you would put your preferences in HKey current user /software. Sorry, what's that?
Or you can do an INI file.
The comment is, or you can do an INI file. That's correct. They still use that. Now let's talk about debugging a little bit. We got the 64-bit debugger, but obviously if you're trying to debug something on a remote machine or user's computer, you might have that option to debug it through the IDE. You could use Microsoft's debug view. So if you wanted to output some messages using system debug log, you can view these through this debug view program. And if you set up Windows error reporting, the crashes that you receive, there's sometimes a dialog that pops up, says, send a report to Microsoft. Clicking that button sends that error with the crash dump to the Windows server. And if it's our error, if it occurs in the framework, we'll get a report and we can debug that. So in Windows single versus multi-instance, most apps are actually multi-instance. But to set up single instance, we like to use mutex. Just a quick note about declares. We first look in the libs folder, so my application libs. You can also just create a libs folder that we look in as well. Then we check the current directory or any DLLs. And lastly, we check the system directory. So you could have a declare in your app that calls a third-party DLL. And if you wanted to distribute that, just stick it in your libs folder or the current directory of your executable. All right, any questions? Yes? The question is, are we ever going to get back to the day we have a single Windows executable? I think no. Sorry, I think no. Any other questions?
You said these examples that you just showed us all, they're in the SDK.
So the .NET control example I showed you, the source code. Sorry, the question is, are the examples available in the SDK? Only the .NET control example is. So the rich WPF rich text box that I demoed, all the source code to that is available in the plugins SDK in 2018 R1. The other examples should be available in the XCC stuff that you got sent. Yeah. Okay. Oh, yes.
If I have a list box on Macintosh and then I compile the application for Windows, on Macintosh the header is shaded, but on Windows it's all washed out. There's
It's all washed
no
out.
color in the header. Is there anything you can do to create some contrast between the header and the body of the list box?
All right, so the question is, the list box header on Windows looks all washed out. It's hard to differentiate between the header and a row. Is there any way that you could change that? Well, no. We are simply drawing with a theme style, so that's the Windows look, fortunately.
You can always cover it with canvas and create your own header.
The comment is you can cover with a canvas and create your own header. That is now possible. Bob?
Is it possible to implement things like true PV grid, things like that, in the Xojo application?
So the question is it possible to implement a true database grid?
Right, that's for Great City, there's component one, there's some other fairly complex grids that are available. Is it possible to use them? And why?
So can we use a database grid? And the answer is, I'm sure if someone wrote it, if .NET, WPF.NET supports it, you could probably pull that in. Obviously, you could also use a list box to do that as well.
Some of them are available as COM objects.
Some of,
Hopefully demonstrated you can bring those in.
yeah, you could bring those in, not easily, but.
So you're saying that Xojo supports full COM interface with all ActiveX?
Okay, so the question is, does Xojo support full COM interface? And the answer is mostly true. There's some, yes, it's mostly true. Most of what you need could probably be done. Not easily, I'm not gonna say it's easy, but it can be done. All right, if there's no other questions, thank you.